Another reason that we might have an inter-VLAN routing issue if we have multi-layer switches is that we have a layer 3 ether channel interconnecting our switches. Maybe I've got a switch here, I've got a switch here, and we have a series of links between these switches. I'll just do a couple, and they're bundled together in an ether channel. And traffic is not flowing over that ether channel. What could be going on? Well, this is a tricky one, but we need to be careful about the order of operations. When we define this virtual interface that's made up of multiple physical interfaces, we call this a port channel interface. And you can run into issues if you start assigning physical ports to that port channel interface, that logical interface, before you ever create the logical interface. Another issue that you might have is that you're using the wrong protocol. You see, Cisco's been doing EtherChannel for a long time, and Cisco has their own protocol for negotiating the formation of an Ether channel between a couple of switches like this. And Cisco's protocol is called PAG-P, the Port Aggregation Protocol, but there's an industry standard as well. Link Aggregation Control Protocol, LACP. And if you're running PAG-P on one side and LACP on the other side, that could cause issues. Before we take a closer look at those issues, let's take a look at how do we set this up? How should we set this up in the first place? Well, remember, we want to create the port channel interface first. Then we can start populating it. That's what we're doing here. We're creating this virtual port channel interface. In fact, let's do this. I just want to take you out to the live interface, and let's set this up on switch SW1. I'm going to go into global configuration mode. And let's create, out of thin air, this virtual port channel interface. I'm going to say interface port-channel, and I'll give it a locally significant identifier. I'll call it 1. And because this is going to be a layer 3 ether channel, I don't want this to be acting as a switch port. I want it to be acting as a routed port. I'm going to say no switch port. Just like we would take a switch port on a single interface on that switch and convert it into a routed port, we just now converted this switch port virtual interface, the port channel interface, we just converted it into a layer 3 port. All right, now that it's a layer 3 port, we can assign an IP address to this virtual port channel interface. I can say IP address, and I'll say it's 20.20.20.1 with a 24-bit subnet mask. And now that I've created the port channel interface, now I can populate it. Order of operations is important. Let's populate it now. I'm going to go into to interface range. Interface range is a really efficient way of assigning or giving the same command to multiple interfaces. I want to put interfaces gigabit 1/0/13 all the way through 16. I want to put all those interfaces, all of those ports, I want all of them to belong to this port channel. So instead of going into one at a time and saying you belong to this port channel, which we could do, I want to do it all at once. I'm going to say interface range gigabit 0/1, or excuse me, 1/0/13, and I'm going to say this is going to go all the way through 16. Notice my prompt is now interface range. The command I give next is going to apply to gigabit 1/0/13/14/15 and /16. And I want to make all of these ports members of this virtual port channel interface. I'm going to say, first of all, no switch port. They're going to be members of this layer 3 ether channel. I need to make sure that they are routed ports as well. No switch port for all of those. And then I'll say channel group 1 mode. And let's use some context-sensitive help here. And here we start to see some of those different protocols I was warning you about. Notice we've got the industry standard LACP. We've got Cisco's PAG-P, and we could use different protocols. Let's assume that we're going to use PAG-P in this example, and I'm going to set this side to desirable. Let's think about what that will do for us. What if the other end of this ether channel is also set to desirable? Will an ether channel form? Yes, it will, because desirable says I'm going to respond to PAGP frames. If I see somebody sending me a PAGP frame saying, hey, let's be an Ether channel, I'm on board with that. Let's do it. But Desirable also says, not only will I accept PAGP frames, I'm going to initiate them. I'm going to proactively send a PAGP frame saying, hey, other side, would you like to be an Ether channel? If I have Desirable on both sides, that should form the channel. Or if I have Desirable on one side and Auto on the other side. Notice what Auto does. That's PAGP also, and it's only going to form an Ether channel. If we set it to Auto, we're only going to form an Ether channel if we receive a PAGP frame. We're not going to be the initiators. We're not going to suggest, hey, other side, let's be an Ether channel. No, we're just sitting there passively waiting for the other side to suggest that we become an Ether channel. Once we see the PAGP frame, then we'll jump on board, then we'll form that Ether channel. I'm going to say mode desirable in this case, and that is the proper way to configure a layer 3 Ether channel. Now, what we're about to discuss are a couple of issues that might prevent this from working correctly.